So on Wednesdays we wear pink, the second funniest day of the month, the 24th. Haha. Okay. You guys will be able to use and understand trig functions for right triangles. We're finishing up 7.4/5. We started that before break. We reviewed it a little bit just a moment ago, and now we're going to finish it up. So we're going to be using what we call these trig ratios, the sine, cosine, tangent. We just said, hey, we're going to use SOHCAHTOA to help us remember what each of the ratios is. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, thus forming SOHCAHTOA. Yes. Always circle the angle that is given to you. We will know this to be the reference angle. What does it mean when somebody says in reference to something? What does that mean when someone says in reference to something? Like in reference to this, this is that.
You can look at it and it helps you.
Okay? You can look at it and it helps you. Okay? Seth?
Like you're giving credit.
Okay? Somewhat like you're giving credit to. So sometimes your references can be people you're giving credit to. Okay? It can also be saying, hey, go back to this, and from there you were able to go. Okay?
Go to this for this reference.
Okay? So yep, for this reference, this refers to this. It goes back to this. Okay? In like a book maybe. Okay? When you apply for the job, you have to put down the references, right? Okay? Yeah. So that's where they can go back to the references to find out more about you. Okay? Things like that. So reference, and when we're saying the reference angle, that's going to be the angle we're given. So just a moment ago when we circled like angle A or angle B on that problem, and I said, hey, from there, let's label opposite, adjacent, hypotenuse. That angle we circled would be the reference angle there. Does that make sense? Okay, Gucci. Sometimes we'll see this angle being labeled theta. Oop, didn't mean that. Theta is essentially 0 with a horizontal line through it.
Isn't that like Greek?
It is a Greek letter. Very good, Seth. So theta is a Greek letter. Here's what theta means.
Letter.
Okay? Theta is, in math, is basically x for angles. So a lot of times in math, especially later in math, like pre-calc trig especially, and beyond, we'll see this symbol, theta, whenever we're talking about the measure of an angle. So instead of saying like x degrees, we'll call it theta. Or we'll call the angle theta. Instead of calling the side or the side length x. Okay? Does that make sense? Okay? It's basically just another variable. Mr. Kossel, is it wrong to use x for an angle? No, it's not. Thanks for asking, okay? It's just we'll typically use theta later on. And so I'm introducing it now, saying, hey, this is something that we use, okay? Yes?
Pre-calc and trigonometry,
I don't know what you mean by that.
because you're learning Greek.
Oh, yeah, so you learn a little bit of Greek, but you're not learning it in the actual Greek setting, though. We just learn how we use that in math. So yeah, we do now know that theta is a Greek letter, and we learned that in a math class. So in that way it is.
That's all we know, then.
So we're going to label the opposite leg as well, the adjacent leg, and the hypotenuse in every problem. And did we just do that last problem that we did together? Yeah, we did label all those. We form the trig ratios as fractions. Sine of angle A is 8 over 10. Okay, we just had that. Then we simplify the fractions. Well, 8 over 10, that's really equal to 4 over 5. So that steps 3 and 4. So that's how we use those trig ratios, and we just did that. Now, this choosing a trigonometric ratio is going to be based upon, we're going to use that to try and find side lengths. So sometimes, for these right triangles, we don't have enough information to find side lengths by the Pythagorean theorem. We said we could use that Pythagorean theorem, a squared plus b squared equals c squared, to find the third side of a right triangle. If we know 2, we can find the third. Then we said, okay, we also have these special right triangles. Throwing it back here a bit before spring break, we have 30, 60, 90s and 45, 45, 90s. Do those sound a little familiar to us? Okay, we had our little road maps, right? You guys remember those road maps we drew?
Yeah.
And said, hey, we start here, we go to here. How do we go to here? We multiply or divide by this or that.
You take a plane.
Okay, got a job. So we said if we have one side of a 30, 60, 90 or 45, 45, 90, we can find the other two. What do you do though when you only know one side and it's not a 30, 60, 90? So in this case, this would be a 35, 55, 90. That's not one of our special ones. 30, 60, 90, and 45, 45, 90 are the only special ones. This is not a special one. But we only know one side. We're going to learn to use trigonometric ratios, our trig ratios, sine, cosine, tangent, to find the other two sides. So we say, hey, we have another way we can find these, in case we don't have that information. So what we do is we mark the reference angle. So in this case, it's going to be the angle we're given. So in this triangle, what angle are we given? 35. So I'm going to mark that. I can circle it if I want. Yes, it says 2. Then I'm going to label the hypotenuse, the opposite, and adjacent side based on that reference angle. So in reference to this angle, which sides are what? That's what it's saying there. So 14 is the what? Hypotenuse. X is the which leg? Opposite leg. And the other side is which one? Adjacent. So we have the hypotenuse. And what side are we looking for? The opposite. Right now we don't really care about the adjacent, to be truthful.
I mean, it's not very important.
So you can either circle the two you want to use, or we can just note the two we want to use. Now the two we want to use, by that I mean what you want, so what you're looking for. So in this case we're looking for opposite. And what you have. We have the hypotenuse length. We are looking for the opposite length. So that's where this comes in here. After we label those sides based upon our reference angle, we are using the opposite and the hypotenuse. So according to this, which one involves both the opposite and hypotenuse? Sine, cosine, or tangent? Which one involves both the opposite and the hypotenuse? Sine, cosine, or tangent? Sine. Now that also goes back to SOHCAHTOA. So I'll write down SOHCAHTOA over here. It's almost like it's important. If we look at this, knowing that there's going to be kind of this divide between every three letters, opposite, hypotenuse, O and H. Which one of these three groups involves both O and H? So, we're using sine. Now let's say we had A and O. If we had A and O, which of the three would we use? TOA. O and A and O. So if I had H and A, which one would we use? CA. So depending on what we have, and in this case we have the hypotenuse, and what we're looking for, the opposite, we're going to be saying opposite hypotenuse, we're going to look for sine. So what we do is we set up our ratio the best we can. So we, like I said before, we take sine, cosine, tangent of the angle. So we took sine, cosine, tangent of angle A or angle B. In this case, we'll take the sine of 35 degrees. Because what's my angle measure? 35 degrees. That's going to be equal to, sine is or equals blank over blank. What does it finish off with? Sine is?
30.5.
No, so we're not just typing in our calculator this time, believe it or not, actually. So sine is blank over blank.
Opposite over hypotenuse.
Opposite over hypotenuse. So what's my opposite leg's measurement right now?
90.
X. What's my hypotenuse measurement? 14.
Would X be theta?
Great question. Would X be theta? So we said theta will be the angle potentially. So in this case, no, because it's a side length. Good question, though, okay? Bringing that back. So here, we created we created a math problem here, okay? We created an algebra problem. Sine of this angle is equal to x over 14. This is a math problem we can solve. What we're trying to do is find the side length x. We want to get x by itself. So how do we get x by itself? Well, we always ask the question, what's happening with x? So what is happening with x? It's being divided by 14. So how are we going to do it, Seth? Multiply by 14 on both sides. So that's exactly what we'll do. We'll multiply this side by 14. Some of us might prefer to call that a 14 over 1, right, Tyler? Okay, some of us might prefer to call that a 14 over 1. Make sure we're writing this down if we haven't already, guys. 14 and that 14, those reduce, don't they? And then we have to multiply this side by 14 as well. So we have 14 times the sine of 35 degrees is equal to x. Now, I heard the question, how do we do that? Okay. Well, what you can't do is take 14 times 35. Can't do it. That's not what it's asking us to do here. It's not saying multiply 14 and 35. It's taking 14 times the sine of 35. Everybody have a calculator out, whether that's one of my scientifics or whether that's on your phone. Either is fine with me. Okay? The Apple calculators will have to go through a slightly different method to do this, but that's okay. Than on the regular scientifics. So, I will first talk to those not using Apple devices. Okay, or not using Calc 84 on an Apple device. Okay, if you have an Apple device, I suggest Calc 84 because it's amazing. It's an app. You can download for free. There is a paid version, but you do not need the paid version. So,
what's the paid version give you?
I don't remember. So, 14 times the sine of 35 degrees. Literally what you type into your calculator, 14 sine 35 parentheses. It's literally what you type into your calculator. You type this in as you see it. That's the nice part about true scientific calculators. You can just type it in as you see it and it works.
My phone just gave me an ABS light.
Okay. Who has an iPhone calculator here they're using? Okay, here's what you do first. You type in 35. Then you have it turned sideways, which you do already, which is good. Then you push sine. Not sine H, just sine. Okay? Then you, and it gave you a new number, right? Probably a decimal. Okay?
0.5 or 0.5735.
Okay? Multiply that by 14. So what you have to do first on the iPhone calculator is you first have to find the sine at 35 degrees and then multiply that by 14. And the scientific calculators or the Android calculators, you can do that all in one step. Okay? Now, let's say to 2 decimal places to the nearest hundredth, what do we get for x to be approximately?
8.03.
8.03. Did anyone not get that to the nearest hundredth? If you did not get that, raise your hand now so I can help you get that. Okay? You always want to check to see if our answer is reasonable. If we had gotten a number bigger than 14, would that be reasonable? Why not?
Because
It's too big?
the hypotenuse has to be bigger than both sides separately,
Okay.
but both sides together have to be bigger than the hypotenuse.
Yeah, the hypotenuse has to be bigger than both sides separately, but if you were to add those other two legs together, it should be bigger than the hypotenuse, right? Yep, very good, very good. Going back to the rulers, I like it. That stuck with you. Okay. Any questions on how we did this? We will practice a couple more like it, okay? Any questions on how we did it? Okay. So guys, SOHCAHTOA, huge, huge, huge.
What's rad?
Okay? Rad means radians. So just like how we measure angles in degrees, say it's this many degrees, radians is another method to measure them. Similar to like centimeters and inches. Yes. Yes.
There's a whole another function in my calculator. What the?
Is it the radians versus degrees?
I don't know what it is.
Okay, so it's not another function.
It's extra. It just doesn't all fit. There's a button and it'll pull.
Oh, like the second button?
Yeah.
Yep. It pulls up like the inverse sine, cosine, tangent, and the hyperbolic inverses as well.
What is TANH? Ta.
So TANH is hyperbolic tangent.
Okay.
It's a pre-calc concept.
I don't know.
Sorry, it's a trigonometry concept, really, but like the actual class trig. All right, moving on. So before we talk about this word problem, you don't have this in your notes, and that's okay. You don't need it in your notes. Look up here. We're going to pretend this line is horizontal. Okay? Everyone understand that? We're going to pretend this line is perfectly horizontal. Okay? Okay?
Angle of depression.
Okay. Play pretend with me, guys. We're pretending this line is perfectly horizontal. Now, from a perfectly horizontal line, we can go two different directions with an angle. We can either go up or down. Okay? Well, up, we're going to call it an angle of elevation in reference to a horizontal line because it's elevating. Elevating means to go up, right? Like an elevator goes up and down, but it's going up is elevating. Okay, does that make sense? Okay. If something is depressed, we often probably most think of the mental state of depression, okay? Or the
Great Depression.
I think of the hydraulic press personally.
okay? So what does a hydraulic press do, Kenny?
Exerts a great force.
Okay, exerts a great force where? On what? How?
Down.
Down.
Well, I guess you can do up too.
Okay?
The
But
Great Depression.
they compress things down, right? And it makes things smaller, right?
Yeah.
Okay? So similarly, that's the exact same idea as what we're getting at here. Depressed is a downward state. That's some push-ups, my dude. And so you still owe yours as well, okay?
Can I just do wall
So
sits?
Bailey, that's 10 for you too. Okay.
I can't. It hit. I was gonna do it from here, and I probably would have made it, but I was like, no, I don't want to do 10 push-ups.
Man, play dumb games, win dumb prizes, okay?
I tried to go out of my way.
All right. So when it's depressed, it means it's a downward state. So if you're in a state of depression, okay,
You don't want
or you are actually diagnosed with the state with depression in general, it's a downward state. Okay, it's a downward emotional state. Okay, that's what that is. So that's where our definition of that comes in. So we're saying an angle of depression. We're not saying it's sad, it's lonely, or any of those other emotions that can be tied to the mental state of depression. Okay, we're saying it's down. Okay, that's what depression actually literally means. Yeah. Yes. Good luck. So once again, it's from a horizontal point. So if I'm looking straight ahead, that would be horizontal. If I'm looking here, is this a horizontal line for my eyes? No. What now? What about now?
It's elevation.
No. What about now, though?
Maybe.
It is. Okay, it's going to be a horizontal line for my eyes that look straight forward. So anything
Looking at-
above that create an angle from this horizontal would be an angle of elevation in comparison. Anything below would be an angle of depression.
It's like sea level.
Now here's the thing, though. Here's the thing. If I have an angle like this, I don't have a way of telling whether this is an angle of elevation or depression. Because you could look at it from each way, right? You could say, hey, it's going up here from the bottom, so it's going to be an angle of elevation. Or you could say it's going down from the top, being an angle of depression. We don't know.
What if?
So that's why we say it has to be from a perfectly horizontal. Because if I just have this, and we pretend that line's horizontal right here, it's a little bit better. Okay, we'll say it's horizontal. We know this is an angle of what? Elevation or depression? Elevation. It's a lot more obvious to us here. Because we're going in reference to a horizontal, or what we're at least being told is a horizontal.
It's like the Nebraska Department of Roads. We'll pretend it's horizontal.
That's funny. Okay, this angle is what type of angle? Depression. We can tell because based upon that horizontal line, okay, it's going downward.
We'll pretend it's straight.
Can we tell? Can we tell on this one though? No. All right. Going on to example 2, okay? We have 2 more examples left in this section. Example 2. Story problem. Woo.
Story time.
Bailey's excited. She loves these. Okay. Bailey was just telling me, actually, She stopped in my room Monday after school and said, "Hey, Mr. Kossel, you know what I've been really missing over spring break, especially?" I'm like, "What's that, Bailey?" She's like, "Story problem." I'm like, "Bailey, you know what? I'll throw a couple extra in just for you." And she's like, "Really?" I'm like, "Yeah." And she was really excited about it.
It's never happened.
Oh, it totally happened.
No, she was in advisory with me.
Why would he lie?
She was in advisory with you after school?
Yeah, also after school. She's with me after school.
Yeah, well, she came down with me after that.
I
Did you see her walk home?
No, I saw her off the building.
Okay, well, maybe she came back in.
Oh.
You can't?
It's locked.
Huh. Interesting.
No possible way to get back in there.
Yep. Yep. I can't get back in the building once I leave.
There's no going back.
Yeah, because you went home.
She doesn't have a pass.
What?
One day Mr. Kossel
Yep.
left and sat in his car for like 20 minutes, just sitting there. He was just sitting there.
It wasn't for 20 minutes. It was for like 2 minutes.
No. It was 10 at least. Because me and Chris were doing the weird panorama photo thing.
Yeah, you guys were, is that what we were doing?
Yeah.
Okay.
He was like walking.
A rope!
Yeah.
Staked 20 feet from the base of the building, goes to the roof, forms an angle of 58 degrees with the ground. To the nearest tenth of a foot, how long is the rope? Okay? What's one thing I always say is helpful in story problems?
The rope is 20 feet. It
Nope.
says right there.
Circle all the information.
A rope. Wait. No. Don't.
Okay. Underline, highlight, circle important information like Seth said. What's probably important here?
20 feet, 58 degrees.
Okay? It's staked 20 feet from the building,
From the base
from the base of the building.
to the nearest
Okay.
10th of a foot.
Okay? And then the angle of 48 degree, an angle of 58 degrees with the ground. Okay? And we need to know to the nearest tenth of a foot. Okay? And we want to know what to the nearest tenth of the foot.
How long is the rope?
Okay? How long the rope is. Okay? If you didn't notice, what did Gregory do right away? He pointed out what two things? He pointed out 20 and 58 degrees. Why would Gregory point out those two things right away? They're numbers. This is a math class. Numbers are probably important. Okay, what might be another helpful thing on a word problem, guys?
Picture.
Pictures. So we don't have a picture.
Oh, no.
Oh, darn. We can draw one.
Oh,
Okay?
I don't have hands.
It's like the
I'm blind.
it's like the calm panic calm meme. Okay, we don't have a picture. Panic. We can draw a picture. Calm.
Don't have
Okay.
hands.
Okay. Oh.
Keep 'em straight.
Okay.
Don't have
So,
hands.
anyway, voice off. So we can draw a building. We know we have a building, right?
Oh.
We're here for realism, Landon.
Okay, here's our building.
It's 3 stories. Duh.
Okay. So here's our building. What else do we know about this picture we have?
There's a rope.
There's a rope. Where's the rope at?
20 feet from the base.
20 feet from the base of the building, so like over here somewhere.
It goes to the roof.
And it goes to the roof. So like this is the rope right here.
That is a straight line.
Okay, yes.
It's a rope. It has floppiness. Come on, Landon.
And so what's that dashed line at the bottom? How long is that?
The ground.
20 feet.
No, that's from the base.
Because that's from the base of the building. What kind of angle would most buildings make with the ground?
90.
Okay, right? You hope it's 90.
Nebraska.
Okay.
Nebraska be like
Okay.
90.
All right. Now, we are also told we have an angle of 58 degrees. Where am I placing this angle? I have 2 other spots I can place this angle
Ground.
with the ground. So is that up here?
No.
No, it's going to be down here with the ground. The rope makes that with the ground, so it's going to be between the rope and the ground is 58 degrees.
What if it's a 4-story building and there's just a base?
What if it's like a triangle?
Well, that's completely theoretical anyway. All right. So what are we trying to find here as our answer?
The opposite or is it?
The length of the rope, which is the hypotenuse here. So what can I call that for now? Cool.
Or, yeah, just that.
Cool, X. Hey, we might have enough information to set up a problem. Do we have a reference angle?
Yeah.
Circle our reference angle. What are the other, what side do we have? 20, which is the
The adjacent.
adjacent. It's the adjacent leg. What are we looking for?
The opposite.
Nope. Opposite's over here. We're not looking for that.
We are.
Are we trying to figure out how tall the building is?
The hypotenuse.
We're looking for the hypotenuse, the one across the right angle. So, for our trig functions, going back to SOHCAHTOA, knowing we have the adjacent, we are looking for the hypotenuse. Which one of these three sine, cosine, tangent involves both the adjacent and the hypotenuse? Ka. So which trig function is that, sine, cosine, or tangent? Which one starts with C?
Cosine.
Cosine. That's our hint, guys. What letter does it start with? Oh, it's that one. Does that make sense? Any questions on why we're choosing cosine? If you have them, please ask now. Okay. So we're going to say cosine of the angle. Of which angle? 58 degrees. Cosine of 58 degrees is equal to blank over blank.
X over 20. Or 20 over X.
20 over x. Why does it have to be 20 over x rather than x over 20, guys?
20 comes right.
Because the 20 comes first? Because the 20 is the adjacent, and it's adjacent over hypotenuse. Okay? Questions on that setup? Is this pretty similar to our last problem? Yeah. Except for this time our variable's where? The variable was on the top last problem, right? So where's the variable now? The bottom of a fraction. Do we want the variable to end on the bottom of a fraction?
Why? I don't think so.
Okay, no.
So can our angle be the 90 degrees? The 90?
Nope. So when you're doing cosine, that's a great idea. When you're doing sine, cosine, tangent, you have to take one of the non-right angles. Yep, great question. Okay.
I feel like he probably wasn't, but
No, I mean, it's a good clarifying question.
take it.
If it wasn't, I'd be honest with you right now. I feel like you could take it. All right. So we have x on the bottom. Well, last time we multiplied by whatever was on the bottom, and we got x by itself.
Yes.
Do we want to try dividing by 20 now? Would that work?
No.
Okay.
Yes.
So if we divided by 20 like that, or multiplied by 1 over 20, those 20s would reduce, right?
Yeah.
But then we'd have 1 over x. Do we want 1 over x?
Oh.
No, the x is still on the bottom, isn't it? That's still an issue. Dylan, put it away.
By 20. You flip it.
Oh my calculator.
So, what did you say, Kenny?
You multiply by 20.
Multiply by, okay, let's see what happens if we multiply by 20.
Flip it.
That'd be
Negative.
400 over x. Oh, that didn't help.
Just flip it. Flip it.
Flip it, multiply by what?
1 over 20.
X over
Yeah, 1
negative
over
20.
20.
Okay. So rather than multiplying by x over 20, actually, right idea, we're going to multiply by x over 1.
No way.
We're going to multiply by x over 1. Because what are these x's going to do? They're going to reduce out to 0. To me to 1, thank you.
You can't do 0.
You're right. So we'd have 20 over there. Now, if we multiply one side by x, what else do we have to do? Do that to the other side. So we're going to have x times the cosine of 58 degrees is equal to 20.
That's not right.
Now, is x by itself right now?
No.
No. So, what is happening with x, though? It's being multiplied with the cosine of 58 degrees.
Yeah.
There's secretly 1 in front of it, too. It's being multiplied by the cosine of 58 degrees. How do we undo multiplication? Divide. So it's multiplying with the cosine of 58 degrees. So we're going to divide by the cosine of 58 degrees. We're not dividing by 58 because we're not multiplying by 58. We're dividing by the cosine of the angle because we're multiplying by the cosine of the angle. Now, what's anything divided by itself, guys?
Oh, my brain hurts.
0.
Nope. 1. Those reduce. X is equal to 20 divided by the cosine of 58 degrees. Is x by itself? It's not? Oh, it is. So now what we do is we have to type this into our calculator. I'm going to first start with the non-iPhone calculators of how to do that because it's easier. Okay? You type in 20 divided by cosine 58 parentheses. Then you hit enter. You literally just type it in as it is.
Oh.
So that's what the problem
20 divided by, technically no, but I want to get in the habit of it because later on problems it'll mess you up if you don't. This problem it won't, other problems it can.
Is it times 20 or divided by 20?
20 divided by this. Now, if you have an iPhone calculator, a little bit different. If you have an iPhone calculator, you first have to find the cosine of 58 degrees. So you have to put 58 cosine. Now, when you do 58 cosine, you get a long decimal, right?
Yeah.
Okay? So what we have to do is we have to write that out again and say it's actually 20 over whatever that long decimal is to 4 decimal places. So, Gregory, what would that decimal be to 4 decimal places?
5299.
0.5299. Dylan, do you agree?
Yeah.
Okay? So now you have that and you write it down. And now you type this in your calculator. 20 divided by 0.5299.
I got it.
This is why
Okay?
Android is superior.
Okay? I would agree like that. So to the nearest tenth of a foot, it's 37 point what?
7 4.
To the nearest tenth, it's 37 point what?
7. Sorry.
7. There you go. So the rope is approximately 37.7 feet. Is that the same answer everyone got? If not, raise your hand so I can help you get that.
We should be contractors.
You can learn now. We can help with this.
I don't know why we need to.
This is an actual thing that contractors will use sometimes.
Yeah,
Wait,
but
what?
like you just grab the tape, right? You go.
Yeah, but sometimes you're able to figure out exactly what the other side needs to be, or if we need to build the ramp at exactly this angle, or we can also use what we're going to learn next section, which is an expansion of this,
Wait, how tall
to
is
learn
the
how to
building?
find what angle do we need to build this ramp at, that kind of thing. So we can figure out not how to just make it pretend it's straight, but actually straight.
How
That's
tall
why
is
we
the
pay
building
engineers to do nothing. So we're trying to.
Okay.
then? Is that as small as like a building? The roof is only
Yes.
Oh, God.
It's a tiny 3-story building.
It's for the hobbits.
Yes, it's for the hobbits. Hobbiton. All right. Any questions on that, guys?
Do you have a question?
Just that one.
Yeah.
All right. Move on to the last problem here.
Oh, yay.
To where?
Are we doing 7
I didn't hear what.
No. Example 3. A pilot in a plane. A pilot looking at an airport from her plane. The angle of depression is 29 degrees. If the plane is at an altitude of 10,000 feet, approximately how far is it from the airport? When we're asking how far, I'm talking how far laterally.
How can you see how could she see the airport at that distance?
She has binoculars.
The pilot looking at the airport. Wait.
She has some good eyes.
Oh, never mind.
Let's not make this more complicated than it
She's
actually
got like one of
is.
those super zoom kids. She's got a telescope.
I mean, they say your eyes can see many miles if there's nothing obstructing your view.
Yeah, there's way more.
So if you're just looking down, like at the airport, you could probably see that.
Oh yeah, some of you guys in here can't.
Because 10,000 feet is less than 2 miles.
I can't see two.
Like, let's realize that for a second. 10,000 feet is less than 2 miles.
The farthest you can see is 3 miles away.
Okay? So 10,000 feet is how many miles? Less than 2.
I don't know.
So is this maybe somewhat reasonable?
Yeah, sure.
Oh, okay. Cool.
I'll accept this.
Okay. I love the inquiry. Okay? Underlying key information. What's some key information here? Seth, what's one thing?
Angle of depression is 29.
Angle of depression is 29 degrees. We probably need to know that. We just learned about an angle of depression, okay? What else might be important here? Gregory.
Well, the altitude's 10K.
Okay, altitude's 10K, 10,000 feet. Okay, what? Yep, slightly less than 2. But boom. Okay. Do we need to know, what else do we need to know? Okay, approximately how far from the airport? Okay. Do we really need to know it's a pilot? Do we really need to know it's a her?
Yeah.
Okay, not for the problem. Okay, it's kind of extra fluff information. Okay,
Just a person can just see that far from 10,000 feet. Just know the context. They can just see an airport from 10,000 feet. There's
Yes.
no
I
context.
mean,
if they're
Yes.
not-
All right.
islands have to have
What? Hey, guys. What's the other thing that's going to be helpful for us here? Underlying key information. Picture. Draw a picture. So what do we got to draw here?
An airplane.
An airplane.
Yeah, buddy.
No.
Let's see this airplane.
I'm gonna do mine side.
Airplane. What kind of airplane is that?
What airplane?
It's a beautiful airplane.
It's not a beautiful airplane.
It's a Cessna.
Okay, if that's not a beautiful airplane, I don't know what is, guys. Okay. So I drew an airplane, a bear plane.
A bear
Could you imagine a bear that could fly? Okay, anyway, that'd be a bear
I
plane.
would be terrified.
Airplane. Okay, what else do we probably need to draw?
Why is this kind of looking like a
Airport.
Airport. We probably need to draw an airport. Okay?
Rossi, you didn't
And I'm actually just going to draw the little tower. And we're going to pretend this tower is just as tall as the airplane somehow. This tower is secretly reaching 10,000 feet in the air, okay? For my drawing purposes, because I am not an artist, okay? Maybe somebody who's in Mrs. Sedlak's class could actually draw this better than I could. Me, this is not the most I can do, okay? Okay? Cleo could probably do a better job of this than I could. But this is probably the limit of my artistic ability here, okay?
Don't draw a Flappy Bird.
There you go.
Also, that's a little embarrassing.
You're embarrassing, okay? So we know the plane is how high?
Dang.
Kind of looks like a nuclear
How
rings.
high are you?
We know the plane is 10,000 feet in the air. So we know vertically there's a distance of 10,000 feet. Do we know the horizontal distance? No, that's what we're trying to find.
My airplane kind of looks like a nuke.
Trying to figure out how far it is horizontally. Okay. So we could also make a hypotenuse here, couldn't we?
Angle of depression.
Now we're told an angle of depression. Now wait, an angle of depression has to be from a horizontal going downward. Do we have any horizontals going downward? We have a horizontal line here, but it's going up, isn't it? And we don't have a horizontal here. Now, if I drew an imaginary dashed line in here, could that be basically the same thing and do the 29 degrees right here? Does that make sense? Or no? Okay, Elizabeth's saying doesn't make sense. Okay, so if this dashed line was a horizontal line, so if the pilot's looking straight from their line of sight and they look down for this angle of depression toward the airport, that angle would be 29 degrees. Does that make any more sense? Maybe a little bit. Okay, Kevin, can you wait a couple minutes or no? Okay, because we're almost done with this. Is why. Okay, now if this is 29 degrees. Is this distance still x up here?
Yeah.
Okay. Is this distance over here still 10,000 feet? Yeah.
Theoretically.
So really, could we just do it from this triangle instead of the other one?
Wouldn't it also be the same for the other one?
Yeah, you could have this angle be 29 here, right? It could be an angle of elevation looking up as well. Could be that. Okay, somebody at the bottom of the airport was looking up toward this plane.
The pilot's looking at her plane from the airport.
Yeah. Yeah. Not the pilot, but someone else, okay? Now, shh. There we go. So, based upon our angle, what side are we given? The opposite. Based upon our angle, what side are we looking for? Based upon our angle, what side are we looking for? The adjacent is next to it. What side do we not care about right now?
Hypotenuse.
Hypotenuse. Dylan, put that away. Thank you. So, we care about which two sides right now? Adjacent and opposite. So, of our three trig functions that form SOHCAHTOA, we'll be looking at TOA. Which trig function is TOA? Tangent. Starts with a T. TOA starts with a T. TOA. Opposite over adjacent. So tangent of the angle, tangent of 29 degrees, is equal to blank over blank. What is the opposite over adjacent here? 10,000 over x. Questions on how we got this set up? Billiam, do you have this written down? Billiam, where are your notes? On. So, is this a similar setup to what we had last problem here with the variable on the bottom? Okay. What did we do when we had that variable on the bottom? We couldn't multiply by, or excuse me, we couldn't divide by x. That didn't work. We had to multiply by x to get it out of the denominator. Our first step is to get that out of the denominator. Yes, it moves it over to the other side. That's okay. So we have x times the tangent of 29 degrees. It's not 29 times x. It's x times that entire operation. Is equal to just 10,000. So now, we say, okay, well, how do we get x by itself? It's currently multiplying with tangent of 29 degrees. So we have to divide both sides by the tangent of 29 degrees.
What's your parentheses?
Yes.
I'll get confused with that one.
So, those divide out on the left-hand side. X is equal to whatever 10,000 divided by the tangent of 29 degrees is. And remember, we're finding approximately how far it is. And let's go how far to the nearest tenth of a foot. X would be approximately 18,040.5 feet. If anybody does not get that in their calculator, please ask so I can help you get that. Correct. At the end? Yep.
Wait, what? Oh.
Looks like an S.
It does look like an S. Yes.
Yes.
Yes. Maybe somebody is learning how to write square foot and they're doing it wrong. All right. Any questions on that? Okay, I'm happy some of my 18 guys got that one and liked it.
Wait, what?
All right.
You called your A-team guys?
Yeah, some of the A-team guys, yeah. Are you A-team guys?
Yeah, but that's generalizing. That's like,
I'm sorry, is that not part of the reason you got more of the hands-on working joke?
yeah, it's because we're stupid, but that's not.
No, that doesn't mean you're stupid. It means you're more oriented toward the hands-on stuff.
I know he's stupid.
Okay, I'm not saying you are or aren't stupid. I'm not commenting on the intelligence right now.
I got SpongeBob socks on right now. Come on, man.
I mean, that's big brain to me. Yes.
Alright.
Your homework is the rest of that worksheet I gave you, okay?